Hi everyone. In the given problem statement, we are going to solve partition list. Given a head of a linked list and a value x, partition it in such a way that all the nodes less than x come before the nodes greater than or equal to x. So you should be able to preserve the original relative order of the nodes in each of the two partition. Let us take the example of, let's say we have a node or linked list with 1, 4, 3, 2, 5 and again 2. Now we're going to have two stacks. One would be the lower and another would be higher. In the lower right, our value of x is been given as 3. So is 1 smaller than 3, which is going to be added to the first one while traversing. Now 4 is on the higher side, it will be added to the fourth array. Now 3, right, is greater than or equal to k, right, or x, so it would be added to here. 2 is smaller than 3, so going to get added to here. 5 is higher than 3, so it's going to add it to here, and at last we're going to get 2. Once we're going to get through, so we are going to form our new list with these elements. So it would be 1 which got added. Now we are going to traverse the second element and the other element, so it would be 1 2 2, and on the higher side it would be 4 3 and 5. Thus, using two arrays, right, we're able to solve this problem efficiently. Here, if I look into it, the time complexity would be big O of n for the first case to traverse, and the second case where we are going to add or create a new linked list out of it. To do 2 big O of n, or we can easily say big O of n. Only thing is that you'd require two stacks, so our memory complexity would be higher. So that's fine for us and it would be a pretty efficient solution. So let us jump to the Python code for this one. The first thing that you would be requiring would be creating a dummy variable which you're going to initialize with list node. Then you're going to have a curve value which is going to be dummy. Now we're going to have two list which is lower and higher. Once that is done, right, while we are going to traverse the entire linked list, so while head is true, in that case val equal to head dot val. Now if val is smaller than our x, in that case it would be lower dot append val. In case it's equal to or higher than the val, it would be going to the higher, so higher dot append dot val. Now we are be creating our new list. So for first thing we're going to do, we're going to traverse to the entire of the lower array, and then we're going to traverse to the higher array, and in this way, right, relative order is also going to get maintained. So for each in lower curve dot next equal to list node of each, and curve equal to curve dot next. Similarly, for each in higher, curve dot next equal to list node of each, and curve equal to curve dot next. And at last we are going to return dummy dot next. Let me run the code. I hope there are no spelling errors for taking time. Not sure why. Memory limit exceeded. Let me check what's happening out here. Yeah, I forgot to add a very small error that I have made, which is while we also have to point to the next head element, right? So head equal to head dot next. Now let me run the code. I hope this time there would be any issues. Let's check. As you could see, the public test case is passed. Let me submit the code. And as you could see, it passed successfully. Although it is giving 11.49, I'm not sure. Let me submit it back again. I hope the performance would improve. It improved to 100% because the solution is pretty efficient, and in that sense, right, the code is pretty good because the complexity would be big of n. That's all. So that's all for this video. See you in the next one.